To swim through thick microscopic fluids, microbes use a tiny biological engine called the bacterial flagellum. Take this single bacterium. To propel itself forward, it doesn't just wiggle, it builds a true mechanical propeller. The machine starts at the base, anchored deep inside the cell envelope. This is the basal body. An inward flow of hydrogen ions physically forces this motor complex to spin. This biological power source is known as the proton motive force. But because this spinning motor is buried inside the rigid cell wall, there's a mechanical problem. If it attached a stiff rod directly to the outside, the twisting force would snap it. To solve this, the bacterium builds a flexible universal joint out of FLGE proteins. This hook safely transmits the motor's intense torque outside the cell. Finally, the hook connects to the filament, a long, hollow helix made of FLCI proteins. This structure acts exactly like a propeller blade, catching the fluid as it rotates. To remember this assembly from the outside in, just think FHB. F for filament, H for hook, and B for basal body. When all three components lock together and power up, the entire propeller system spins up, and that single bacterium finally blasts forward through the fluid to find food. Bacteria steer using long tails called flagella, arranged in 5 patterns based on simple prefixes. First up, imagine a bacterium acting like a boat with a single motor at the back. This one-tail layout is called monotrichous. Just think of the prefix mono, meaning one. Next, some bacteria place exactly one tail at opposite ends of their body for balanced steering. This double-ended setup is called amphitrichous. The prefix amphi translates to both ends. Then there's the cluster approach, where a dense tuft of tails sprouts from a single pole. We call this lophotrichous. Remember it with the prefix lopho, meaning lots at one pole. Moving on, if you combine the previous concepts, you get thick tail clusters at both ends. This extreme layout is called amphilophotrichous, literally combining both previous root words. And finally, common bacteria like E. coli are entirely covered with tails across their whole surface. This layout is peritrichous. The root peri reminds you they wrap the entire periphery. By learning 4 simple prefixes, mono, amphi, lopho, and peri, you can instantly decode the blueprint of almost any motile bacterium.